Here I am today with Scott Barrett, and last night he started talking to me about helmets, and I thought, wow, he knows so much, it'd be great to capture that and create a little information session. So the first question I had was, my helmet makes wind noise, and when I turn my head sideways it reduces it a fair bit. So when I'm looking forward while flying my paraglider, I have this hissing sound. My ears may be different to everybody else's because I have tinnitus, and the hissing may be more sensitive to my ears. Everyone hears everything differently. But I'm annoyed with the wind noise, so I have tried several things. I've put foam strips to stop the air flowing between the visor and the helmet. I've put fluffy bits on over the ears and over the straps, and that has reduced it. I've put tape over the cooling ear vents, which have mesh inside them, and I put a bit of fluff over my GoPro mount thing, and I've thought of a few possible ideas but haven't been able to solve it. And a good way to test it is getting on my push bike and trying the different things. Scott just asked if I took this visor off, have I tried it? I haven't yet. But now I'm going to hand it to Scott and ask how I can improve the wind noise and any other concerns that I should have or think about using this helmet.
Okay. This is a nice helmet made by Charlie. It's an Air Sports certified helmet, and it's quite nice in that it's got a nice thickness of foam in the front and across the top of it. A lot of Air Sports helmets don't have that. There are other Air Sports helmets such as this one. Have a look at the thickness of foam that's in the front of the helmet. It's quite a bit less than the foam in this one. And quite unfortunately, CIVL in their wisdom, the bureaucrats decided that these helmets were safer than anything else and we had to have them. This is a snow sports certified helmet which has twice the thickness of foam compared to the Air Sports certified helmet. And when we had protested that CIVL was trying to make us fly with less safe helmets, eventually they relented and allowed us to use snow sports helmets as well as Air Sports helmets. Often an Australian bicycle helmet is quite a bit safer than an Air Sports helmet because they have not been so concerned with having minimal frontal area, but been really concerned with all of the other aspects of safety. We'll talk about the other aspects of safety shortly and what a helmet does. For Ian's concerns, noise is something that's related to the swirling of air. It's about turbulence. The hissing that you hear is where the air is detaching and detaching. It's vortices, turbulent air flows behind ridges and things like this. We often have experienced a lot of wind noise standing into the wind, and you can hear when you turn your head that you get a reduction of wind noise when you turn your head, and an increase when you're straight onto the wind, and a reduction again. Just try that in the wind one day. Try it when you're riding your bike. Find that if you put your fingers, just put a finger up in front of your ear when you're riding a bicycle, it will reduce the amount of wind noise because the turbulence is not right at your ear. You've got you don't have the air velocity right next to your ear anymore, and it significantly quietens down the wind noise. Some time ago there was a product that was made for bicycle helmets that's called a wind finger, and the wind finger does the same thing as putting your finger in front. You wrap a larger diameter piece of cloth around the front riser of your helmet strap, which reduces the amount of wind noise for the wearer. So looking at this one, we could be looking at where you might find there's air that's racing past edges and lips and things like that. And the thing to do is to experiment is really the way. take the visor off, see if that makes a difference. Put your fingers up and try to seal gaps on one side compared to the other, and find out what it might be that's causing the extra noise. With regards to helmet safety, on a paraglider, having anything on a helmet that can catch a line when you've got all of your bag of washing wrapped around you can cause reinflation issues, and having GoPro mounts and that kind of thing is just an additional level of hazard. The other thing that I don't like about a helmet like this is the use of a visor. I don't like using visors myself, and I race without a visor, and it's been shown in wind tunnel studies that helmets without visors are most often better than helmets that do. They have less drag to not have a visor. And the reason for that is that when you have your face filling this front of the helmet compared to having a visor, all of the air comes up at these ridges and features of your face and slows down, and then you end up with the remaining air flowing smoothly around the helmet. It's a lot like having a big open cell on the front of a paraglider. You haven't got the full complete rounded airfoil or anything like that. You've got an open cell. Does that cause more drag? And the answer is no, it doesn't. The air in front stagnates, and the free flowing air that's approaching the paraglider wing splits up and goes around the stagnated air in the front of the leading edge vent, and it acts just like there was a smooth nose on the airfoil, until of course you go to extreme angles of attack and the like. But for the most part, the flow is quite neat.
The topic of the visor, the reason I have a visor is to protect my skin from the sun, which is severe here, and so I use this visor to try and reduce the sun. And I did do experiments with a UV meter, putting the visor in front of it, and discovered that it does not cut out 100% of the UV, but there are different types of UV. So it may cut out 100% of a type of UV, but I can still get burnt through the visor, but it does reduce the UV. So that was my main purpose of the visor.
Yep. The way that I go about that is I use sunscreen, and it's important to know what kind of sunscreen to use. There is cheap sunscreen and expensive sunscreen, and I use children's sunscreen on my face anywhere above my eyes. I'll use children's sunscreen just as a regular thing in my day, and I use the cheaper sunscreen from my eyes and below. So I usually end up doing my face all in children's sunscreen. Children's sunscreen, when you sweat, any of the sweat that comes down, it's not going to cause sting in your eyes. That's what children's sunscreen does in comparison. When I'm flying, I like to use a stick of sunscreen. There's some very nice sheer zincs where you can apply the sheer zinc to your entire face, and sheer zincs do not run. So you do have to be careful putting on balaclavas that you don't wipe it off, but that's a really good high protection kind of sunscreen. With helmets, the functions that a helmet does, they include, they're tested in many different ways to assess what kind of Ian also uses kids' sunscreen.
Which Annette investigated, and being a pharmacist, looked at everything and told me this is the one I need to use so that it absorbs and doesn't hurt my eyes.
Excellent. The one that I've been using is a Neutrogena shear zinc. It comes in a stick, like the old deodorant sticks. There are a number of different kinds of sticks, and that particular one is not particularly important. Lots of them will work, and just about all of them are suitable for not hurting your eyes when they're sticks. So helmets are certified, and they do a lot of testing, and the testing is done to assess the different ways that a helmet protects you. So the sorts of things that happen, the design features of a helmet are often internal padding. People think, oh, internal padding, all the sponges and bits and pieces that make it all comfy and make it safe. The padding is something that doesn't actually add safety to you. What it does is it can make it so that the helmet fits you nicely and that it's comfortable to wear. Some of the important things about the internal padding is that it's not bouncy, that it doesn't store energy and then give it back to your head in an impact. In my helmets that I race with, I remove all of the padding and buy the smallest helmet that I can without having any internal padding so that it fits my head. So I've got the maximum amount of crushable foam, and I haven't wasted the space with this comfort padding. I'm trying to get my cross-sectional area of my helmet reduced. And if we were to compare cross-sectional areas of helmets, which one is wider, which one has got the lowest cross-sectional area, and then the next question is, well, which one has the lowest coefficient of drag as well? So I start with removing the internal padding because it doesn't have a safety function. So that's padding. The next thing is crushing. So the helmets that we see here all work by destructive crushing of the internal foam. When an impact happens, the foam crushes, it absorbs energy, and that energy hasn't been absorbed by your brain. Of course, your brain still gets some of it, but the idea is to try to stop your large forces being applied to your skull, and then having your brain come and smash into the front of your skull. That can happen in straight line motion. It can also happen in rotation. So helmets are being evolved now where they have also got very good protection from rapid rotation. So part of that will be that the shell can move relative to the inner skin. Also, that the outer shell is not likely to grab on anything. So if you were to slide onto asphalt or something like that, foam will grab, but a hard shell will skid and slide. So abrasion protection, the ability for it to not wear out on asphalt if you're travelling at speed is really important for things like bike helmets and motorcycle helmets. You start to use Kevlars instead of plastics, and you want it to skid instead of ripping your head off to the side as well. Air sports helmets are best being a continuous external skin where there's nothing to grab on sticks and branches and things like that. If you were to crash into a tree, you just want them to slide off. Whereas if you would have vent holes, which there are vent holes on this air sports helmet, on this ski sports helmet, and what you would usually see on Australian bike helmets, sticks can be caught into holes and then give you rapid rotations and transfer loads to your head and neck. So a solid skin is better.
Have you taped up the holes?
The holes are taped up, and the reason why they're taped up is that I didn't want them to disturb the airflow until I get to the turbulators.
And is that some special strong tape so that it can't be pierced?
No, it's not.
Okay.
Ideally it would be. More ideally, it would be a continuous shell.
Yeah.
And the turbulators are there to, not so much to reduce the drag on the helmet itself, but the Reynolds numbers that we're using on helmets, they're at a critical sort of a Reynolds number, where numbers for the Reynolds number for my helmet at around 40 kilometres an hour. They're just underneath the critical Reynolds number, where you're trying to select between whether round and smooth is better, or dimpled and rough and turbulated is better. And at the speeds that we're running at in paragliders, it's just a little bit better to have them turbulent as opposed to smooth. And by the time you're flying hang gliders at 75, 80 kilometres an hour, it's certainly in a better Reynolds number to allow you to have turbulators. But the turbulators are not there so much for the small advantage in being turbulent or smooth. They're there to be able to create pressure recovery after the helmet and onto the back of the harness. So you're energising the boundary layer so that it's more likely to be reattached over a gap as you're going into the back of the harness. So there's another couple of things.
So on that, where I use a submarine style of harness that inflates behind my head, I have a gap of about this much where there's a inflatable thing to try and connect that boundary layer. Do turbulators improve that connection to the...
They do improve the connection.
Right.
So there's two things I would do. Is I would change my helmet to a round one, because when you've got pressure recovery provided by the harness, the pressure recovery features of having a short tail that doesn't exist anymore.
Yeah.
But there is a disadvantage to having a short tail, is because for 20% of the time you're looking around and exposing the short tail to the wind.
Yep.
So the tail is actually causing drag.
Yep.
Get rid of the tail.
Yep.
Yes, apply turbulators. And this sort of technology is being used in the trucking industry. You have a look at vortex generators that are used on the back of the cab that then reattaches the flow onto the trailer, so that the airflow bridges the gaps nicely. Another couple of certification issues on helmets are the retention on the straps. So they're tested for particular load ratings on the straps, and there is a slight variation in the load retention on an air sports helmet compared to a bike helmet. But the big ones, the big differences are in things like when they're testing curbside, hitting sharp curbs with the helmet, and the amount of coverage that the helmet provides for you. What does it protect? Does it protect the top of your skull? Does it protect around your ears? Does it protect on your forehead? So where does it come to, and what protection is provided around the back? And a lot of bike helmets have quite a strong focus on the amount of foam in the rear, because you're often sliding along and hitting your head on roads. Whereas in paragliding crashes, you're most often compressing spines and legs and things like that. More likely to have forward impacts on your helmet. Other considerations for the helmet are headsets. So I've greatly favoured having helmets where my press to torque exists within my helmet, and just hide a press to torque in an easy to feel location. So you can press to torque on the helmet, and then all you need to do is you have a microphone hidden in your chin strap, and then you have speakers in one earpiece, or I've been using one radio per side of my helmet. One is a VHF and one is a UHF. One's for air traffic and one's talking to drivers and other pilots And then I'll have, in that case, I'll have 2 microphones hidden down on the chin strap and a headset per side. If I've only got one headset, I put the speaker on the opposite side to where my Vario is for when I'm racing, and I often like to fly without a Vario when I'm not racing, just as a point of deliberate practice and the way that I enjoy my flight. Another option is to run your press to torque so that it's permanently fixed on the harness. I've also have a harness where I've got fixed press to torque, one on each shoulder, one for each headset, and so I just connect the headset into the harness, and then the harness contains all of the press to torques and connections into the radio, so it's only one connection. For my free flying in my more simple harnesses, I like to have the press to torque here and a connection directly into the radio from the helmet. The connections are important, that you don't just use speaker wires or anything like that. We use very fine copper in cables like this, which can be quite easily broken. So good headset cables, unlike this one, are usually spiral coiled, and they're filled with dyneema. And so any structural loads are taken first of all by the cable being coiled and flexible, and it doesn't bend very much as you're moving your head around and going through the daily use of the helmet. Curly cords do a lot to make a headset robust. Curly cords that are they're made for pulling and yanking, and they have dyneema in them, which means that the dyneema takes the load and the copper does not. They're also terminated so that there's a lack of pressure points and bending points on a gradual transition, so that everything, the cable's not always bending in this one place. The loads are the greatest. Microphones are best hidden in what we call a dead cat, which is something big and fluffy, and you'll see extremes of this when you see TV reporters have got their sound crews and they've got something that's actually more cat-sized and very fluffy. And when you have one, to make it work very well, what you do is you pull at it and fluff it up as big as you can and get lots and lots of fur sticking out. And as you've got that fur sticking out, it makes a nice gradual transition with lots and lots of small bits of turbulence. It just doesn't leave you with the wind noise of the air going around just one obstacle. It makes a nice gradual transition in speed from free flow back into the microphone. It gets rid of that wind noise without having to have any kind of filtering or anything on your radio. Helmets are the aerodynamic functions of a helmet. We did talk briefly about cross-section. Cross-section is one of the things that matters a lot to what the drag is going to be. You can have drag made by it being a particular shape, but then if that shape is big, then you end up with drag coming because you've got more area. So some of the first things that I do is to get the area down, and then to improve the aerodynamics. I fly without a visor. I fly with a round helmet because I'm looking around a lot, and I've got pressure recovery in my harness, not on my helmet.
And so pressure recovery, that's that streamlined shape of your harness.
That's right. Yes. Or pressure recovery is the streamlined shape of the helmet. Of course, that only works when you're facing forwards. Yeah.
Yep.
So, what questions do we have about helmets?
So you were talking earlier to me before this about the numbers that
equivalent area and percentage of drag of the helmet. So how much difference does it make using a draggy helmet compared to an aerodynamic helmet?
Right. So in the bike world, if you go onto all sorts of resources, they're comparing one helmet with another and which one's better, and they measure things in watts. You can go to Google Scholar and you can have a look at scientific reports of tests in wind tunnels by aerodynamicists, and they talk about reductions in drag in points of CD, and they've got comparisons of visors to non-visors and all of that sort of stuff, and made some really nice numbers.
So the CD's the coefficient of drag?
Coefficient of drag, and they've been showing that helmets without visors have better coefficients of drag. If you go to YouTube and you have a look at test results for different bike helmets, that they'll show differences in aerodynamic performance between helmets of up to from 10 to 35 watts of difference. When you're riding a bike, they measure it in watts, not in coefficient of drag. But when you run the numbers, watts is how quickly you expend energy. And when you're flying a paraglider, that's how quickly you expend energy is the rate at which you lose your altitude. So I ran the numbers for what that means, flying a paraglider kinds of speeds and sync rates, flying at around 40 kilometres an hour, to have 10 watts of additional energy loss. It's about the equivalent of having more area of drag of about 100 mil by 100 mil. That's 10 watts at 40 kilometres an hour. These are the speeds that bikes are tested at, 40 to 45 k an hour, when they're claiming their wattage difference. So when we're looking at the sync rates on a paraglider, if you're syncing at 2.5 meters a second at doing 40 to 45 k an hour, to have an extra 8 watts of loss contributes to about 0.3% of your sync rate. So it's something that you're going to not see by someone having a different helmet, but you're likely to see difference from someone having a different glide line. If you choose to compete at a very elite level and you're competing for a week and a half or something like that, and you've done many small things, you can have a percentage point difference over a week can add up to some seconds on multiple courses, on multiple races. And we've seen, when I've run the numbers, the difference between first place and second place at a World Championships was the equivalent of someone stopping and turning for 3 thermal turns over the course of 2 weeks, and that was the points difference at the end between winning and getting a second place at a Worlds. So a Worlds, this talk isn't going to be for someone at a Worlds, because they're doing these things and they're trying their best to reduce drag at all prices, and for most pilots, this sort of thing is going to, I would hope it would be a second consideration compared to the safety that a helmet will give you. The difference between this helmet price, which I have been racing at the last World Championships with this helmet. This is a $30 helmet available from Aldi, which is an air sports. It's permitted in air sports. It is a snow sports helmet available for $30 from Aldi, and you're allowed to use it in a CIVL sanctioned World Championship event. This is an air sports certified helmet, which has a lower level of safety, a lot less foam in it, and it's many hundreds of dollars. You might pay $400 for a helmet like that, and it offers less safety. And a $30 helmet which offers greater safety, which I'm using at a World Championships. So I've run the numbers, and I've got a very functional helmet, and I've been racing beside many other pilots. Many of the best pilots I've seen using round helmets World Championships. So it's flying next to Nene. He was using a round helmet. There are people, good people, who have crunched the numbers and they know where their performance comes from.
And for paragliding, I've always been nervous of using a helmet like that for if I ever go down through some trees in a tree landing, of having that back tail caught on a tree branch as I'm falling down.
Yeah.
All right, thanks very much, Scott. If you've got any questions, that's Scott Barrett. And
Ask Ian.
all right, see you next time.